Hi, this video is HL7 version 2 versus HL7 FHIR, or perhaps different standards for different times, or maybe even better yet, the benefits of FHIR. My name is Terry Sipple. Let's talk about when HL7 version 2 was first introduced. The year was the mid-80s, and there were all sorts of new technology coming out. There was the Nintendo Entertainment System, which starred Mario 1, 2, and 3, which by far the best-selling games of the time because they were the only ones. There's a little company down in Austin named Dell Computers, and they were coming out with this new thing called the personal computer at a lower price so that it would be for a broader audience. And as you can see, it came with multiple floppy drives and gigantic fans to try and keep the system from overheating. There were multiple different kinds of monitors you could get in those days. There was green and there was amber. Over here we have a modem. Modems had doubled in speed. They were up to 2400 baud, or 2,400 bits per second, twice what they had been only a year before at 1200 baud. One, of course, they were connected to your phone line. There was a company out in Seattle that was coming out with a new product called Windows 1.0, and it was beginning to develop graphical user interfaces for computers so that you did not need to use command line interfaces to specify your executable that you want to run and pass in the arguments. Okay, drag and drop didn't exist yet, but hey, it was a start. And then let's talk about society. There was all sorts of new music coming out. On the top Billboard list, we had Wham! And Madonna and Foreigner and Chaka Khan and Daryl Hall and John Oates and Tears for Fears and Dire Straits. Okay, I still like Tears for Fears and Dire Straits. And look at these haircuts on the Wham! Folks. So if I have to still explain in this year that the technology that was developed in the 1980s is not the same as what you have in your home today. For example, how many of you have a Nintendo Entertainment System in your home, as it was, version 1.0? Or how about a Dell computer with a bunch of floppy drives? Or, heaven forbid, a 2400 baud modem? And yet, HL7 version 2 is still prevalent throughout the entire industry. It's not only prevalent, it's what makes the world run today. So why is that? I had a physician come into a trade show booth fairly recently, and he said, I'm already getting the labs and all the values I need in my EHR. If it ain't broke, don't fix it. But here's the thing. It is broke. How did we get here? HL7 version 2, when it was started, was intended to go from one system, perhaps a lab management system. We're going to look at CBC results, and we're going to send one message to one other system, an oncology system perhaps. This message didn't really matter too much because it was inside of an intranet and you could change it. So this system would define what it was going to send, and this system would define what it was going to receive. HL7 version 2 is text-based messaging system. However, each message is composed of segments, which we'll look at in just a minute. And the segments were actually pretty advanced because it was kind of like an object which could be reused. HL7 version 2, as I said, sends one message from one computer to one other computer. It uses TCP/IP, but not HTTP or HTTPS because those hadn't been invented yet, but at least it does use TCP/IP. The transport layer is actually called MLP, but it is unique to HL7 and nothing else. There is no security or encryption in HL7 version 2, so anything going across this wire is open text. There's no security whatsoever. The delimiters, there was no JSON or XML. So to determine the different pieces of delimiters were used, and we'll see an example in just a second. Those delimiters were hats and pipes. Get really used to counting hats and pipes in version 2. Version 2 is a suggestion. Not much is required. Now you could argue that that's true in HL7 FHIR as well, and that wouldn't be wrong. But HL7 version 2 also did not have the concept of use cases driving profiles, and in turn making things required. There was also, initially, no concept of multiple systems. So what that means is that the assumption was that it was one system sending one message to one computer. There was no concept of multiple systems here listening to the same message, as well as there was no coding initially involved. So SNOMED, LOINC, RxNorm, HCPCS, if you want billing. None of those coding systems were involved in these original HL7 version 2 message. Now, HL7 version 2 did evolve to allow for codes as well as multims, but not in the early days. Then there's the infamous Z segments. A Z segment is when I don't feel like figuring it out or when there's not a standard. Rather than going to the standards committee and trying to come up with a common method of doing things, I can throw anything I want into a Z segment and I can say I sent it out. Whether or not anyone can receive it or interpret it is irrelevant to me. So that really is kind of not advantageous for true interoperability, but they exist everywhere. Then there's the standard itself. HL7 version 2 is one gigantic PDF. Actually, it's a series of gigantic PDFs. There's no website. You open up the PDF and there are no links to the table of contents, so you use Control F to navigate the HL7 version 2 PDFs. However, HL7 version 2 is simple, it's fast, and it was effective, or at least it was effective for the first several decades. Let's look at an HL7 message. I chose to look at an ORU message, which is a results message, which happens to be a radiology report. So down this left-hand side, you can see that HL7 included segments. So this is the message header segment. This is the PID or patient identification segment, patient visit, the order information, the results, the observation information, another observation segment. And then down here we have a CTI segment, which I have to be honest, I don't remember what that is. And then there's a Z segment. So you can see there's a bunch of information in this Z segment, and I have absolutely no clue what that means, and probably neither does anyone else. So you can see that within this PID segment, you can go and you can evaluate additional information. And here's where we're going to start to count hats and pipes. Now, because I've worked with HL7 version 2 for a long time, I happen to know that patient identifier or medical record number is at PID 3. So to get to the element PID 3, we have to count pipes. So let's start counting pipes. 1, 2, 3. So this is going to be the medical record number. Medical record number, in turn, that element is made up of several different components. I happen to know the first component is the medical record number itself, so there it is. Within an element, to get to the different components, you have to count hats. So here I know that the medical record number assigning authority is PID 3 component 4. So now within the PID 3, let's count to the fourth component. 1, 2, 3, 4. And so St. Joe's healthcare system assigned this medical record number. I happen to know that patient name is PID 5. So go back to here. 1, 2, 3, 4, 5. And sure enough, its first component is family name, second component is Smith. I happen to know patient, let's see, date of birth is 7. Let's look at that. 1, 2, 3, 4, 5, 6, 7. It's blank. Okay. Patient sex is 8. Shoot, I moved my cursor. Let's start counting again. 1, 2, 3, 4, 5, 6, 7, 8. Also blank. So that's how you go about deciphering a HL7 message. You can see that it's not that hard. It's text. And if you can count, you can figure out most of the things in there. So advantages of HL7 version 2, it's simple text. If you're a developer on the sending side, so you're a source system, it's really easy because you put some things into an HL7 message, you decide which one you're going to use, and you send it out. Also called not my problem. That does not help in terms of interoperability. As a result, interface engines have sprung up as a whole industry with an HL7 version 2, and they're going to make it work, and we're going to talk about those in just a minute. HL7 version 2 is simple, and it works most of the time. True story. There was an ECG vendor, and the software developer, this is on the source side. So on the receiving side, it's a hassle to count hats and pipes. But on the source side, what if you make a mistake? In this OBX segment, which is the observation segment, the ECG developer did not correctly count pipes, and so they missed one. So there was not enough pipes. So if you were counting pipes the way you would normally expect to count them, when you got to the results, you would expect your information to be there, especially for lead 1, because it was lead 1, then lead 2, then lead 3. However, they'd counted pipes wrong, and there was one missing. And so when you indexed into the pipes as a computer, because a computer doesn't look at it and say, hey, something's wrong there. For lead 1, they were actually picking up the information for lead 2. So then what we had to determine was if it was this particular ECG system with this particular model, with this particular software version, you had to add a pipe, but you had to be sure to add it in the right place so that when you counted the pipes that you got to lead 1 correctly and it was indexed correctly. However, in the next release of software, the ECG manager fixed the problem. So now you had to check if it was the manufacturer, the model, and the software version to determine whether or not to add a pipe. You can see how this could go wrong. Okay, let's talk about HL7 and the types of messages. The message that I just showed you is an ORU message or results message. Let's go back real quickly. Here's how you tell that. ORU with component R01. So this is a very common type of HL7 version 2 results. What other kind of messages are there? There's an admission, discharge, and transfer. This is probably the most ubiquitous HL7 version 2 message. Anytime a patient is admitted, comes in for a visit, anything, they're going to get an ADT message. These are sprayed throughout the hospital, thousands and thousands, tens of thousands a day. What else exists? We talked about the order message, order for pharmacy, a lot of radiology orders going through here, physical therapy, whatever it is. Here's the ORU message that we just looked at. That's the result message. If they're in black, it means they've been discontinued. So down here you can see query. Well, no one actually implemented because it doesn't work. But down here, here's another message. This is RDE message, a pharmacy treatment encoded order. Well, interesting. Rather than putting the encoding into the order up here, they kind of were profiling, sort of, and they made their own message. But remember, just because one system can support this RDE message, most systems are going to be expecting an ORM message. So you might have to take an RDE message and convert it to an ORM message because this is what's the most prevalent. Now let's look inside of a particular segment. So in the example I showed you, we walked through the PID segment, or the patient identification segment. So how did I know which numbers were which? Well, it's specified in the standard, but let's go take a look at that. So here's how you count. PID 1, 2, 3. So we're counting pipes right now. 4, 5, 6, 7. There's date of birth. 8. There's patient sex. So these numbers along the left-hand column here are how many pipes you're going to count. Let's not worry about 1 right now. So number 2 is patient ID external. Well, if you've been around HL7 version 2, you know you don't use that one. You just don't. But let's look at PID 3, patient ID internal. Oh, and you can turn this into a list. So it turns out, because there's a CX type. So really what they do is they put lists of patient IDs, hopefully with assigning authorities, into PID 3. That's just convention. That's how we do it. PID 4, alternate patient IDs. Turns out not that many people really use that one. They just put it into a list in PID 3 and put in the assigning authority. Then here's 5. We talked about patient name. Actually, quite a few systems do use mother's maiden name. 6. And then we talked about some of these others. But you can see that this number down here is where we get the number of pipes to count. Don't miscount. Now, within one of these, let's talk about, for example, the patient identifier, because it's so important. So PID 3. So we can go and we can look and say what data elements or what components are within this element. That's in the standard. So if I go and look inside the standard, I see PID 3.1 is the ID number. Now here, remember, this is a different standard. This isn't like FHIR. This isn't an ID in FHIR. This is an identifier in FHIR. This is the actual medical record number. There's actually some information for systems that are going to do checksums and make sure that things are transmitted properly, because checksums are not handled in MLP. And so we have some logic in here to do checksums to make things that are transmitted properly over a modem, perhaps. Then down here we have PID 3.4, assigning authority. So sure enough, when we counted hats, because now we're counting hats in this column, element 3, component 4 was assigning authority, or who created that medical record number. So just real quick to relate this to FHIR. In FHIR, this would have been the patient resources, the identifier element, and then the system subcomponent. So in FHIR, you would write that patient.identifier.system. So how does HL7 version 2 actually work in healthcare systems today? It's no longer one system sends one message to another system. Here we have the source systems in blue, and there's going to be hundreds or thousands in a healthcare system. And each one of those for every event is going to send out a single HL7 version 2 message. The one that we looked at was an ORU or results message. So maybe this is a CBC panel. It's going to go to the interface engine. There are a lot of people working to maintain this interface engine. This interface engine is going to take every one of these HL7 messages and it's going to convert it slightly. It's going to tweak it. It's going to put in a pipe here or there. It's going to change something. It might add some information because it's a little bit more robust and it knows some things. It might add a code. It might convert a local code to a SNOMED code. It might know that any result coming from this system should be a particular SNOMED code. So it might just insert or a LINC code. Maybe it'll insert some of the CBC information LINC codes. So after it tweaks, it goes through all of its rules and it tweaks the HL7 message. It's going to send it out or spray or distribute or whatever word to all sorts of clinical systems which are repositories. So for example, it's going to send that order message out to an oncology system perhaps and to an EHR, and maybe it'll send it to billing. More likely it'll be a billing message, or it gets converted to a billing message and sends it to the billing system. But the point is that this is a many-to-many relationship, and maintaining this interface is both powerful, time-consuming, and hard. So let's talk about the disadvantages of HL7 version 2. Scalability. Anytime you send this in, you have to come up with N interfaces on the way out. Scalability is difficult. Not impossible, but difficult. You have to duplicate and maintain all this data. This information, especially to try an ADT message. An ADT message goes in from an admission system, goes through the HL7 interface. It's going to get sent out to every system out there. Not every patient, somebody came in for a broken ankle because they were on a skateboard, seen at the oncology system. And yet, because this is only a messaging system, you have to catch it when it gets sent out. So the oncology system needs to know about all the patients who've ever been seen at that site. So the oncology system is going to have to keep and maintain and update the record for the patient who broke their ankle on their skateboard. Every system gets almost all data. That's your skateboard oncology patient who will never be seen in oncology, hopefully. What else is interesting is that you'll notice that there are no consumers of data. So I should have left some more room over here maybe, but there's nobody to the right of this EHR system consuming the data, which is the gold standard, right? Consuming the data from the EHR. So there's no simple apps. There's no things. Everything has to be developed currently within the EHR. That's expensive and time consuming. I mentioned earlier, there's no query. It's a message-only system. I can't go back and check things. So if you don't catch it on the way out, it's going to be very difficult to get caught up. Now, let's talk about that for a second. Let's say I want to add a new system. So down here in the green, we decide to add some kind of new research system or a dermatology system or what have you. They've missed all sorts of messages, right, that have been going out. So these HL7 interface engines have something else called a rerun, a history rerun. And they can say for the last 2 years, here's my new system, put an address on it. For the last 2 years, rerun every ADT message, including new patients, updates to cell phones, updates to addresses, updates to insurance cards. We're going to rerun from the beginning to the end in the correct order based on time, all of those messages to the new system to get it up to speed. And that's what you do. You rerun history to get this new system up to speed. It is not inexpensive, and it's time consuming. When one system gets upgraded, it usually affects many systems. So if this system gets changed, it usually is going to affect all of these interface rules for these end systems out here. Every message has to be translated. So as I said, you've got to have rules, say maps from this system to this system and this system to the other system. So there's all sorts of rules that need to be created and maintained. There's a ton of time for the IT staff spent on maintenance, and IT staff cost money, quite a bit of money, but perhaps what's even more expensive than that is the opportunity cost. So you have your IT staff working on this little orange box here, creating new rules when they are not adding new applications to your EHR to use the data. For example, maybe there's a new clinical decision support for some rare disease that can help physicians. The EHR doesn't want to implement some new clinical decision support for a rare disease because it's going to cost too much money. And the buy-in, it's not going to apply to very many people. It's only going to probably apply to a couple people. However, we could put an app out here which was to use the information from the EHR if only we had an IT staff that had the time to work on this. Security, there is none. That's a problem in this world of HIPAA and all the ransomware attacks. New staff. When new staff comes into a healthcare system, the time to educate them on what HL7 is, to educate them on what all of these M2N rules are to make all of this work and how to rerun history and what MLP is versus HTTPS, it takes time. So onboarding and training new staff is very time consuming. In HL7 version 2, very little of the data is required or coded. That's something that we discussed earlier. If you're trying to kick off an event or a transaction based on a code, and you know that some event happened, for example, you get a radiology report and there's a PE, a pulmonary embolism, listed in the radiology report, unless there's a code in there which says PE, and it's just a bunch of text, perhaps using some synonym for PE or the acronym for PE, it's very hard to trigger an action. And yet there's very little coded data within HL7 version 2. It's also very difficult to check for data validation, including the completeness and the consistency. So one CBC panel might use one line code, assuming it's coded. Another CBC panel might use a slightly different line code. And finally, it's very difficult, almost impossible, to integrate HL7 version 2 messages with either internet technologies or as a cloud deployment. It's possible. You use a VPN, but it's not easy. All right, 3 cheers for your IT staff. They keep that system up and running. So today and moving forward, how are things changing with the introduction of FHIR? So we still have all of our systems out here, and they're still creating gobs of HL7 version 2 message, and they're still sending them to the interface engine, and it's still doing M2N different combinations and tweaking all of those HL7 messages, and maybe making an order message, changing it into an RDE message for certain pharmacy systems, for orders, whatever it is they're doing. They're going out to all these other systems. But now the EHR has a FHIR interface front end to it, courtesy of some of the regulations coming out of the ONC. Now, systems can begin to query for information. Now, we don't have to tell the oncology system, which, by the way, apparently they've replaced the oncology system, and now we have an information system which uses FHIR, because remember, FHIR is just across these lines. It doesn't need to be based on FHIR, and the EHR certainly isn't based on FHIR. So just like these, the EHR isn't based on the data structure of an HL7 version 2 message, nor is it based on FHIR, and nor is this system probably. But now, rather than having to maintain all of that and back up that database and maintain all the patient updates, when a patient comes into oncology, now they can query the FHIR interface, which has a direct connection, probably some kind of SQL, SQL connection, into the EHR, so they can do a direct one-to-one query to get that information and put it back into JSON format and return it back to the oncology system. Then there's also these little apps, clinical decision support. Perhaps it's a calculator. Perhaps it's a prognosis estimator for a type of pancreatic cancer given very unique or more unique patient demographics. The information doesn't need to be stored in here at all. Once it's queried, the calculator can go out, it can query using FHIR for the information, it can get the patient parameters it needs. It doesn't even need medical record number and patient ID. It can do the calculation, it can display it back to the user on the EHR system. EHR systems today are not great at handling CRUDs, the C, create, so the post, an HTTP post. Creating data in an EHR using FHIR, I don't know that it really exists today in very many EHR systems. So you can get the information, and chances are, if you want to copy the information from what the calculator, the clinical decision support calculator says, you will literally have to copy that information and paste it into your EHR clinical notes, is probably what you're going to do today. It would be great in the future, as we continue to move forward, that we would be able to take that information as structured JSON and actually do an insert into the EHR database as an observation probably, or whatever would be appropriate for that clinical decision support algorithm, with the correct provenance listed and all those kinds of things. and actually insert that into the EHR. We're not quite there yet. But right now, at least you're able to query and read all of the information, perform the clinical decision support, and then this app just goes away. It doesn't retain all that information. It just literally kind of goes back to sleep until it's needed again. But there's no data, there's no patients to maintain, and there's no database to back up. Eventually, that will result in fewer IT resources. All right, let's go through some advantages of HL7 FHIR. Scalable. We're trying to get away from this end-to-end relationship. And as we have more of these systems that are over here in our yellow column, these queries are much easier to maintain, and there's no databases to back up. Think about that CDS calculator example. Lightweight apps. They use the data and then disappear. That is the CDS calculator example. This allows for innovation. Innovation is huge. And this is going to give you the opportunity to have your physicians and your researchers using different types of apps and not make it so expensive. And also hopefully to shorten the wait time for these. Systems can query for information. They do not need to duplicate everything. This is not a message only. There are ways to do subscription, and so if there's some particular type of event that you're listening for example, a diagnosis of pancreatic cancer, to propose the use of a CDS, a clinical decision support prognostics calculator. Those exist. We already talked about the small and easy footprints for these consumers over here, and new system. So we don't need to rerun history if we put a new system here. As the patient comes to a particular department, or the system is aware of additional information that they need, they can go and they can query the EHR or the FHIR interface, really, for this. You don't need to do the 2 to 5 year rerunning of history, which is just bound to cause issues. System upgrade may be easier. I think we need more time to prove that out. FHIR has profiles. That is huge. Not only does it have profiles, but it's computer processable information for profiles. And they can require coded data. Not only can they say you will use LINC, but you shall use LINC for this particular value. And these units of measure if you're going to comply with these profiles. Eventually, IT staff will be reduced. Initially, IT staff will not be reduced. They need to support multiple different types of interfaces and protocols, and this is going to be around for a long time. But hopefully, as more and more of the systems over here grow, it will take less effort because there'll be fewer databases to back up and fewer systems integration. It'll take less effort over time. Opportunity costs. You can begin to spend additional IT staff time on new apps and new upgrades and experimenting with some of the clinical decision support and other things which exist. Security. The banking industry has put so much effort, time, and money into security because they are the banking industry. We can piggyback on top of that. All of those things have proven to be very secure, and the more time that we can spend over here, the less time that your IT staff has to spend over here with all of this open text security. College students, well, for that matter, high school students, middle school students, come out of middle school knowing HTTPS, APIs, and they can understand code systems. The profiles can require codes data validation. So built into FHIR is ways to do validation on objects coming in. And you can quickly get it, return an error message and say, yeah, you guys say you're following the ONC profile, but when we'd run validation on it, before we even accept your information or turn your system on, we can tell you that it's not working. You need to fix this. So clean up your data up front. Remember, garbage in, garbage out. This is how you avoid garbage in. FHIR is architected to be integrated with other internet technologies, such as security, and FHIR is architected to be integrated with cloud deployments. All right, let's wrap this up. HL7 version 2 is going to be around for a long, long time. It's not going anywhere. We do not have the liberty of greenfield systems that we can rip and replace all of this out and replace it with FHIR. Furthermore, EHRs do not accept today FHIR post or FHIR create, so HL7 is going to stick around. However, maybe we can use some of the profiles and go to those interface engines, and we can reflect some of the profile requirements from FHIR, from ONC US Core, for example, and we can reflect that back into the interface engine. So maybe we can make the data a little bit better, even though we're only using the concepts of profile and not any of the of FHIR and not any of the technology of FHIR. ASTP, also known as ONC, CMS, FDA, the CDC, the VA, even Kaiser Permanente, for example, and others are mandating FHIR interfaces. There's two. You can get systems or a person to do something. It has a stick and a carrot. This is the stick. The other thing that FHIR mandates will enforce is some of the quality reporting back to the CMS. As we do more and more quality reporting via FHIR, and it proves to be cheaper and less expensive and faster using FHIR to CMS, I think that'll be another reason for it to take off. Eventually, hopefully we'll see a reflection in the IT staff and resources, both in terms of time and freeing up their time to be able to spend it in other places. With FHIR, the data consumers, here's your small apps, can quickly and easily innovate. This means not every single thing has to be done with inside your EHR. EHRs are great. They don't do every single thing the best that any app in the world could do. So to allow for innovation, experimentation, especially with clinical decision support and really quality measures, security in the cloud, HIEs, FDA adverse event reporting, registries. There's just so many different applications that because FHIR supports security and supports no more Excel spreadsheets that we're sending via FTP. However, you need to request FHIR in any request for proposal that your institution sends out to vendors. You have to ask for it. You need to ask for specific FHIR profiles. Here's your stick. Here's your carrot. Vendors will listen if there's money on the line. So if you do not request FHIR in your RFPs, it's just going to take a lot longer, and you're probably done based on HL7 version 2. I love this quote. AI will not replace radiologists, but radiologists who use AI will replace radiologists who do not use AI. That's by Kurt Langlotz, Dr. Langlotz at Stanford University. I would like to take that quote and morph it a little bit. FHIR will not replace your IT infrastructure, but healthcare systems who use FHIR will replace healthcare systems which do not use FHIR. And on that note, please keep asking questions. Please post questions in the Canvas Q&A, and have a great day. Take care.